Google shipped a game that runs on your own machine. No key, no cloud.
This page can tell whether a language model is running on your graphics card, not by asking you, by trying to talk to it. 3 checks run the moment the page loads. Ollama answering. This site allowed to reach it. The right model installed. All 3 green or the reward stays locked, and there is no way to fake it because there is architecturally nothing else for the app to call. The subject is a real Google project, AI Venture, a grid-based adventure game built on Angular 19 and Phaser 3.9. 13 stars, 6 commits, 71 files carrying a Google copyright header. It is not an officially supported Google product, and that matters later. What makes it worth teaching is not the game. It is how the model backend is wired. The repository ships 6 model backends: Gemini, Ollama, LM Studio, Transformers.js, the Chrome Prompt API, and MediaPipe. Exactly 1 is active at a time. Here is the part worth stealing. Every component in that application injects an injection token called model backend. Not a vendor SDK, not a Gemini client, an interface. Which means switching the entire app from a cloud model to your own hardware is a 2-line comment swap in one config file. Comment 1 line, uncomment another. That is the whole change. 2 values are hard-coded in the upstream service file, the API URL, localhost port 11434/API/chat, and the model string. The browser talks straight to Ollama with a streaming fetch. No proxy, no server in the middle, no API key anywhere in the stack. And here is the single most likely reason a setup silently does not work. The model is Gemma 3:4b. It is not Gemma. If you pull the wrong name, Ollama does not throw something loud and obvious. It returns a model not found error that surfaces as a generic failure, and you spend an hour debugging cores that was never broken. 3 things have to be true before the browser gets a single token back. Ollama installed and running, the model pulled, and the origins variable permitting the page's origin with Ollama restarted afterward. That 3rd one is the one nobody teaches because it stays invisible until something actually needs it. A page served over HTTPS is a different origin from your local machine, so Ollama refuses the request unless you tell it otherwise. The lazy fix you will find in tutorials is the wildcard. Set origins to star, everything works, move on. That wildcard permits every website you subsequently visit to reach your Ollama and spend your GPU. That advice came from a Google AI Studio remix of this project, not from the upstream repository, which ships no course advice at all. Scope it to one domain. This next part is the most useful thing in the class, and it is not documented anywhere obvious. When the probe fails, there are 4 outcomes, and 2 of them look identical. A cross-origin rejection and a completely dead server both surface in client-side JavaScript as the same type error. Same error name, same message, no status code, nothing in the object to separate them. The browser deliberately withholds which one it was. That is a privacy protection, not a bug. If the page could tell the difference, any site could use your browser to map what is listening on your machine. So any tutorial that claims it can detect a coarse error specifically from client-side JavaScript is wrong. It cannot be done. The honest thing for a gate to do is say check both. And the gate on that page does exactly that instead of guessing and sending you down the wrong path for an hour. Now, the part that has nothing to do with Ollama and is the most expensive lesson here. When this project was imported through Google AI Studio, every image in it was destroyed. 0 of 118 PNG files still had a valid header. And the application still compiled. The interface still rendered. The assistant reported that it was building cleanly. The game canvas was solid black. I reproduced it on my own machine to be sure of the mechanism. A healthy PNG starts with the same 8 magic bytes every time. 89504E47. Take that same file, decode it as UTF-8 text, encode it back to bytes, and the header becomes EF, BFBD. That is the replacement character. 127 kilobytes became 233, and the file picked up 53,750 replacement sequences on the way. In the real import, one sprite that started at 161 kilobytes came back at 292, carrying 66,989 replacement sequences. And this substitution is Lossy. The original byte values are gone. You cannot ask the assistant to fix the images because that would be generating new art, not recovering the old art. A green build is not evidence that your assets survived. One more, and it is the one that decides whether you are allowed to ship any of this. The license file says Apache 2.0. 71 files carry a Google copyright header. On that evidence, the obvious conclusion is permissive license, redistribution fine, ship it. That conclusion is wrong, and the repository's own README says so. 9 of the sprites were licensed from a commercial art pack, whose terms read, may not be redistributed, and the license is not transferable. Google is the licensee. Nobody else is. So the reward is not hosted. It is cloned. Clone the public repository yourself, npm install, open the config file, comment out one backend, and uncomment the Ollama one and run the dev server, Chrome or Edge, because Safari blocks public sites from reaching local addresses no matter how you configure Ollama, and that is a Safari policy nobody can work around. The game runs on your graphics card, no cloud model, no API key, no inference bill. If you take 2 things from this, read the README. Not just the license file, because a permissive header does not survive contact with a non-transferable dependency underneath it. And verify what the tool hands you. A green build proves the build ran. It does not prove your files are intact. One line of integrity checking would have caught 118 destroyed images before a week of work got stacked on top of them. The full class is free in the Academy. The pre-flight gate, the 4 failure table, the byte level forensics, and every claim graded as measured, calculated, or asserted so you can tell which is which. Class number 80. Link is in the description, and the game is a clone away.